The first series program that we'll see is this one. Okay, I'll just write down this series. The series is 1, 2, 3, 4, 5 up to the 10th term. So this is the program that we will see. So this question says display 1, 2, 3, 4, 5 up to the 10th term, means we have to display 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is basically what we have to do in this program. Now this particular program we will see using sub procedure as well as function procedure. I'll be doing with both the procedures, but for other programs we'll be only doing using sub procedure. So let's see this program first of all using sub procedure, which is actually the method which we will be using. Okay, using sub procedure. Okay, using sub procedure, what we have to do is, as always, we need to declare. So write declare, then write sub, then write down series. Now SERIE. Now since this is a series program, I'm giving my sub procedure name as series. Now inside this bracket, okay, inside this bracket, whatever input we take, for those values that we have taken input, we write down the variables or the parameters over here. But in this program, in series program, in pattern program, usually we don't take any input. Now, since we don't take any input, there are no values to be stored. And since there are no values, we do not need to write any parameters. Okay, so these two brackets will remain empty since we don't have any parameters, since we don't take any input. So our brackets are empty. Now, usually in other programs, after CLS, what we used to do was we used to write input, but there is no input to be taken. So we do not need to write input. And after input, what we generally have done is we call the sub procedure. Now, sub procedure needs to be called, and it is called through call keyword. So we write call, then we write on series, SERIES, series. And remember a few things, okay, over here. We have already called the series. Now, if you write brackets over here, then as you can see, it is displaying error. As you can see, error has been displayed. Okay, so it means that if our parameters, if we do not have any parameters, then while calling part, brackets are not required. So this is what you have to remember. Now in exam, suppose if you write brackets, then it is going to be a mistake and few marks will be deducted. Usually -5 is deducted for this kind of mistakes. Okay, so better not to make this kind of mistakes and just remove the brackets if there is no parameter. As you can see, there are no parameters inside this bracket. We do not need to write any bracket over here. Now what we need to do is we need to go towards the definition part, which starts with sub, then write down the name of the function procedure series. Here also bracket is not required. As you can see, I had given this bracket, but it will remove it automatically. So you do not need to write brackets over there as well. Only bracket is required in the declaration part. As you can see over here, only in this part brackets are required, whereas here brackets are not required because there are no parameters. Okay, because there are no parameters. Let's go towards the definition. Now here what we'll do is we'll be displaying those, will display that series. So write for I is equals to, now in our series what we have to display is we have to display 1 2 3 4 5 up to the 10 term. So our first term is 1 and we have to go till 10. So our last term is 10. So write 10 because we know the starting value and we know the end value of the series as well, because series is starting with 1 and series ends with 10. So we are starting with 1 and we are ending with 10. Now what we want to do over here is we want to increase the value of I by 1, because we have to I has to go from 1, then it has to become 2 3 4 and so on. So value of I has to increase by 1. Therefore step is not required over here, because if we don't write step, automatically value will be increased by 1. So step is not required. Now what is required is the print keyword. So print has been already written. Now what I want to print is I want to print 1 2 3 4 5 and so on. And 1 2 3 4 5, one by one it will be stored in variable I. So we have to use the loop variable to print our required output. So what we do is we write I over here and write next. And this is all we need to do. And let's see the output. And we can clearly see our output is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, I guess it is quite easy to be understood, this particular program. What is happening is our start value is 1 at the beginning, and our output is being displayed like this. Start value I, start value 1 is being stored in I, which is a valid value. Print I means it will print the value of I, which is 1. Then next will take us to step. No step, I will increase by 1, it becomes 2. 2 is also valid, then it will display 2. Then next will take us to step, I becomes 3. 3 will also be printed. Then 4 is also printed. 5, 6, 7, 8, 9, and it will print 10. After 10, after printing 10, next will take us to step, I will become 11. I will become 11, and 11 is invalid. Since it is invalid, it will come below next. Next means end sub. End sub means our definition part is over. Our control will go to the main module, and it will, this, since it has called the definition part is already over, it will go below call, it will come to end, and our program will be terminated. So this is how 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is being displayed. Now, if we talk about the reverse, that is, if we want to display from 10 to 1, 10 to 1, then what we have to do over here is we write down 10 over here, then we write down 1 over here. Now we have to decrease this time. So write step, then write -1. Run the program, 10 to 1. Now this time what is happening? I will hold value 10 at the beginning. Then it will first of all print 10. Okay, 10. Then next will take us to step. I will decrease by 1 this time. I will become 9. Then it will go towards its body part and it will print 9. Then it is 8, 7, 6, 5, 4, 3, 2, 1. And as soon as it prints 1, again, next will take us to step. I will become 0 and our loop will terminate and we'll get output as 10 to 1. As you can see over here, the output is 10 to 1. Okay, now I'll quickly show you how we can solve series program using function procedure. Okay, it is quite easy. Okay, but this is not how SE curriculum has. So we'll just see for this particular program only. Okay, so using function procedure. So let's write function. Series already there. Here also input is not required at all, so there are no parameters. So CLS, then there's no input. Now what we have to do is we have to call. Now it's not that we will be calling using print keyword. No. Okay, if we call through print keyword, then there will be a little problem. Okay, suppose if we use print keyword, then what will happen? Let's see. Now let's go towards the definition part. Okay, now let's print 1 to 5. Okay, same program, 1 to 5, and step not required. Okay, let's run. Okay, the problem is over here. We haven't changed this sub to function. As you can see, you are seeing output 1, 2, 3, 4, 5, and at the end you are seeing 0, and 0 is unwanted over here. So this is the problem which will occur if we call using print keyword. Okay. Now, since this function is not returning anything, it is displaying 0. Actually, what is happening is print series means it is calling series. So it will go towards this definition part. Here, this will print 1, 2, 3, 4, 5. Now, after it prints 5, this definition part becomes over. After our definition part is over, it will go back to the main module. So since nothing is being returned, it will display simply 0. That's how 0 is appearing over there. Now, if we want to get rid of this kind of problem, then what we have to do is we have to call our function procedure, or we have to call our series using variable method. If you remember, while studying function, we had talked about two ways of calling a function. One is using print keyword and another one was using variable method. So variable method has to be applied to perform series program and pattern programs. Okay, so if we apply variable method, then what we have to do is we have to use any one variable, that is a numeric variable. Suppose I'm using q, anything, you can use any variable, okay, but it has to be without dollar sign, equals to series. So what it is doing is it is calling series function using variable q. So what will happen, once, as soon as the series is being called, it will go towards the definition part. Here is our definition part, and what it will do is it will print 1 to 5, and as soon as it prints 1 to 5, our definition part will be over, and it will go towards its main module. Now since nothing has been returned, value of q will be 0. Okay, remember this line you have to listen carefully. Since function doesn't return anything, series uh, this series will be overlapped with 0, and 0 will be stored in this variable q, and it will go towards end, which is our program will terminate, and this is how our output will be displayed. Hopefully I have made this particular part clear. Okay, let's move towards another question now. And our another question is this one. Okay, 1 2 3 4 5. Okay, this is our next question. That is 100. Then we have 99. Then we have 98. Then we have 97. Then we have 96. Okay, this is our next question. And we have to display this series up to 1. Or let's say up to 0. No problem. So here in this series also, you can clearly see that our first number is 100 and our last number is 0. And the difference, if you look at our difference, here also the difference is of 1. But this time, instead of increasing, it is decreasing by 1. That is the only difference compared to our previous program. We have to start from 100 and we have to reach till 0. And every time it is decreasing by 1. So we know the difference, that is 1, and we know the start value, and we know our end value as well. So these two, 100 and 0, can be used in our program. So let's use it. So let's make few changes over here, because in this part, that is in our definition part, all the printing part happens over here only. So start value 100, our end value is 0. So just make it 0. Now here we are going from a higher number towards the lower number. So we have to decrease, and decrement has to be done by 1. So we write step -1. And whatever values are stored in I, that will be printed. Now I'm giving semicolon as well, so that everything comes in a same straight line. So let's see the output. So we can see our number started by 100 and it has reached till 0. So these are the numbers that are required in our series. Okay. So I hope there is no doubt so far. Now, if we trace this program, then it will look something like this. Our initial value is 100. Okay, our start value, it has already been stored. Then what happens is 100 obviously is valid in this range. So it will go down, print I means 100 will be displayed. Next will take us to step. It will decrease the value of I by 1. So it becomes 99. 99 is also valid in this range. So it will come below. It will print I. So 99 will be displayed. So 99. I'm writing in the same line because there is semicolon over here. And this is how I'm going to write all the programs. All the series programs, I will be using semicolon. Okay. So that everything comes in a straight, in a same line. So basically, we'll be writing semicolon. We'll be using semicolon for series programs. Okay, print I. We are in 99. So next will again take us to step. It will decrease by 1. It becomes 98. 98 is also valid. Print I. 98 will be displayed. And accordingly, it will go till 0. Okay. Accordingly, it will go till 0. After it has displayed 0, what will happen? It will go to next. Next will take us to step. So again, this will decrease by -1. It will decrease by 1. So 0 minus 1 is -1. So I will get value -1. Hope you are not confused. We have already Assume that it has printed up to 0. After printing 0, next will take us to step 0 minus 1 is -1. -1 is stored in 1, sorry, I. And this time, this value -1 is invalid in the range. It doesn't lie in the range. Okay. So once we come into such kind of situation, then our loop will terminate. Termination of a loop means our control will go below next. Below next means end sub. So end sub means our sub procedure will also end. Then it will go back towards our main module from where it has called. So once it goes back to its main module, it was called from this statement, it will come below this one. And below this one, we have end. Our program will terminate over here. And this is the output. Okay, now let me just expand this one. You can see clearly that our output is from 100 to 0. Okay. Okay, now let's move towards another set of programs, and it is this one. Okay, it starts from 1, then 3, then 5, then 7, then 9. Okay, dot 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 is already there up to the, let's say, up to the 10th term. Okay, let's say if this is the question. Now in this question also, let's look at the series. Our series has started from 1, and we do not know the end value. Okay, here end value is, we do not know the last number of the series because it says up to the 10th term, and we do not know what the 10th term is. But if you know the 10th term, then you can use that 10th term in your program, that is in your loop variable. You can start from 1, then you can use that 10th term, whatever is the 10th term, in your as your end value. But here we do not know this, and if we do not know the last value, then what we do is we use a separate variable to print the numbers. We'll be using two variables. One will be loop variable, another one separate variable, which we'll be using to print the numbers that are there in the series. So I'm using a extra variable. I'm using p. You can use any other variable, but that variable has to be a numeric variable. So p equals to, now usually what we do is we always assign our extra variable with the starting number of our series, and the starting number of our series is 1. And you can see the difference over here. It is difference is of 2. And if you look closely, then this particular series is the series of first 10 odd numbers. Okay, starting from 1. First it is 1, then 3, 5, 7. It is the first 10 odd number series. Okay, let's go back to our definition part. So the first number is 1. Okay, p has 1. Now in loop part, what we basically have to do is we have to display 10 numbers. Okay, we have to altogether display 10 numbers. So let's form our loop, which will run 10 times. So 1 to 10 means our loop will run 10 times. Okay, our loop is also ready. Now the only thing that we have to do is we have to print the series numbers. So let's print it. So the first number is 1, and that one we have stored in variable p. So let's use this p. Next time the value of p has to be, next time the value has to increase by 2. So what we'll do is we'll increase the value of p by 2. So p is equals to p plus 2. So this is how we do it. So we have already increased the value of p by 2. So the next time value of p becomes 3, and it will get printed from here. So let's trace this program and see how output will appear. So first of all, the value of I, before I there is p, so let's write p. P is equals to 1. I is also 1. Okay, I is also 1 over here. Start value is 1. It will take 1. Then print p. So it will print the value of p, which is 1. So 1 has been printed. Now next time, after printing p, it will come to this part. Okay, this statement. This statement says p equal to p plus 1, which will basically increase the value of p by 2. So I was 1, it will become 1 plus 2 is 3. So the new value of p is 3. Next will take us to step. There is no step. I will increase by 1. I becomes 2. Print p. Okay, value of p is 3. So 3 will get displayed. P equals to p plus 2. P plus 2 means p will increase by 2. It will become 5. Next step, no step. I will increase by 1. It will become 3. print P. New value of P is 5, so 5 will be get displayed. And once it displays the value of P, it will go to this statement, which will increase the value of 2. So the value of P is 5 plus 2, that is 7. Next will take us to step. No step, I will again increase by 1. And accordingly, it will display up to the 10th term. So this is how loop will execute, and it will display the required series. So let's run our program and see the series. So 1, 3, 5, 7, 9, 11, 13, and so on till the 10 term. So our 10 term is 19. Now, suppose if you all can calculate, suppose if someone calculates the 10 term and he finds it is 19, then you can do like this also. Okay. You do not need to have this extra variable. What you can do is start value, or the starting number is already given in the series 1. Okay, you calculated the 10 term and you found out 19, so you use 19. Then what we can do now is there's one more thing that we have to do, that is we have to use step over here, because value of I is 1. Next time it has to be 3, so it has to get increased by 2, so we can use step, then write 2, and instead of P, what we'll do is we'll be displaying I over here. So this will also give you the same output. As you can see, 1, 3, 5, 7, 9, 11, 17, and so on. Now, whatever method you find easier, you can use that particular method. Okay, suppose if you can calculate and find out the 10 term or 15 term, then you can apply this particular method without using the extra variable. But I prefer the previous one, that is using extra variable, that is P equals to 1. So if you do like this, then you don't need to worry about the last term. Whatever, you do not have to calculate about the last term. Just run the loop as many times as the question has said. At this time, question has asked loop to run 10 times. So 1 to 9, simply write P over here and increase the value of P according to the question. So I find this particular method easier, and yeah, it's easier, and you do not need to calculate the last term. Okay, let's move towards another question. It is similar. Okay, let's do this one. 2, 4, 6, 8, 10 up to the, let's say, up to the 33rd term. Okay, let me do this caps lock. Okay, now if you can calculate the 33rd term, then okay, no problem. You can use that 33rd term as your end value, and you can continue your program. Now here, if you look at the difference is also 2. So this is what we have to mark. Okay, difference is 2. So let's go to our main module. Sub procedure definition, and edit our program. So P at the beginning will be 2, because 2 is the first term. Here we have to display 33 numbers. It says up to the 33rd term. So we have to display 33 numbers. So instead of 10, let's write 33 over here. So this loop will run 33 times, and it will display 33 numbers. So the first number is 2, and 2 is in P. We have already displayed it over here, print P. Now P, here also the difference is same. P equals to P plus 2. So fine, everything is fine. Let's run our program. And this is our 33 numbers, starting from 2, and our 33rd number, that is our last number, is 66. So if you can calculate and get this number, then you can use this in our loop in this way. So you do not need this. You can start your loop from 2. You can end in 66, but you have to use step, and you have to increase the value by 2. And simply you can write I over here, and this is not required at all, and run the program. You will get the same output. As you can see, our series is being displayed. That is 33 numbers are there in total. Okay, now after this, let's move towards another question. And basically, if you have noticed this, then this program is the first 33 even number program. Okay, this can also be referred as first 33 33 even numbers. Okay, now the program that we are about to do is a question that has been asked in SE in one of the years. And the question is like this: 9, 7, 5, 3, 1. So this is the series that we have to print. It starts from 9 and ends at 1. And in this particular program, we know the start value as well as we know the end value. And let's check out the difference. And every time the difference is 2. So in this kind of situation, what we can do is we can use the start value and our end value in our for loop to get the required series. So this is how we do it. Okay, we have the definition part now. So our starting value was 9. We'll keep it as our start value. Our last number was 1. So we'll keep that last number as our end value. And the difference is of 2. But this time the difference is decreasing. In our previous programs, it was all increasing. But this time it is decreasing. So to mark the decrement, we use minus sign as well. So we are writing -2 because we have a higher number at the beginning and lower number at the end. We are going from higher number to the lower number. So for that purpose, we are decreasing by 2. Okay, now print I, it is same. All the statements are all same. Now let's trace this program. At the beginning, P is not required. At the beginning, value of I is 9. Value of I is 9. 9 is a valid number. It will go towards the body part. It finds print I. It will print the value of I, which is 9. Then next will take us to step. It will decrease the value of I by 2. So it becomes 7. 7 is also valid in the range. Print 7. 7 will be displayed. Next will take us to step. Step will decrease the value of I by 2, which will make it 5. Print I. It will display 5. Next, it will again decrease. It becomes 3. Print I. 3 will be displayed. Next step, it will again decrease. It becomes 1. Print I. 1 will be displayed. Next, again step, it will decrease by -2. So 1 minus 2 is -1. But this time the value that is stored in I is invalid. So once it is invalid, it will terminate the loop. Termination of loop means it will come below next. So ends up our series will this sub procedure will get terminated and our control will go towards our main module. It will come below call, which is end. Our program will terminate and it will display this particular output, which is 97531, which is the required series.
Thank you so much for watching. Please do like my video so that I get motivated to create more of these videos. We would appreciate if you would share this video with your friends. And if you have any queries and suggestions, let me know through the comment section. Lastly, please do subscribe my channel and press the bell icon so that you get notified every time I post a new video. Thank you.